And now we have torque, our next topic for our discussion on angular motion. Depending on how we apply a force, we may cause the object to move in a straight line, or we may cause the object to rotate or move in a circle around a pivot point. Torque, or the moment of the force, is the ability or tendency of a force to rotate an object about a pivot point. Say you have an object, we apply a force F on the object in this direction, for instance. Say that we have a pivot point at this location. With respect to this pivot point, the torque or moment of this force is given by tau is equal to plus minus Fd. Torque, tau, is a vector quantity. It has an arrow or bar above the variable. It not only has magnitude, it has direction. The direction is signified by the plus minus sign. Again, by convention, plus for positive direction, counterclockwise by convention, and minus for the negative direction, clockwise direction. F is the magnitude of the force we applied on the object, and D is referred to as the lever arm or moment arm of force F. D, the lever arm, is the distance from the pivot point to the line of the force. Some books refer to this as the line of action of the force. And distance D is perpendicular to the line of the force. Lever arm D is perpendicular distance from the line of the force to the pivot point. If there are several forces applied on the object, so let's say F1, then F2, then F3, and so on, each force will have a corresponding torque. Again, torque is equal to plus minus Fd, so each force has a corresponding plus minus Fd. You have net torque, summation of all the torques applied on the object. So you have torque net is equal to plus minus F1 D1 plus minus F2 D2 plus minus F3 D3 plus minus and so on. Each of these lever arms, D1, D2, D3, are with respect to the same pivot point. So they all have a common pivot point. Net torque is equal to summation of all the torque of the forces applied on the object. When several forces are applied on the object, and the lines of these forces have a common point or intersect at a common point, meaning the forces are basically applied on a common point, the object will move in a straight line according to the net force. But if the lines of these forces are not applied on a common point, they do not intersect at a common point, the object will rotate or move in a circle according to the net torque. So depending on the forces that are applied on the object may experience motion in a straight line, or the object may experience angular motion. And that's it for now. In the next video, we'll continue our discussion on angular motion. In the next video, we'll take a look at angular dynamics. So thank you for watching.